Picture a canvas tent. Right. It's pitched in Oma's backyard. The sun is just beating down.
Yeah, and inside, it's a sweltering 50 degrees Celsius.
Exactly. I mean, most people would be desperate to get out of there. But inside, there's this student named Kesser, and he is fast asleep.
Just deep in a literal fever dream.
Right. And he's dreaming about the hidden mechanics of water. So, welcome to today's deep dive, where we're unpacking Kesser's dream to see if it holds, the secret to life on Earth.
It's such a brilliant setup, honestly, because it forces us to look past those standard textbook definitions of H2O we all learned.
Well, yeah, because we usually think of water's behavior as just a closed case.
Exactly, but at the microscopic level, it is anything but static. I mean, researchers at Cambridge looked at the world's smallest water drop, just 6 molecules.
Oh, right, the one where the hydrogen bonds act like this chaotic dance floor, constantly swapping partners.
Yes, they are just constantly shifting. And Oxford noticed a similar thing happening between 40 and 60 degrees Celsius, where water's conductivity and refractive index just start shifting around.
And didn't scientists in Stockholm look at supercooled water under electron microscopes and realize it's constantly changing phases too?
Yeah, they did. But that brings up a massive problem. If water is this chaotic, shifting mess at the molecular level, how does it maintain any functional structure when it's crammed inside the walls of a living cell?
Right, that's the exact question that leads into the core of Kesser's dream. The theory from biomedical engineer Dr. Gerald Pollack.
Which is the proposition of a fourth phase of water.
Right, so basically when water sits next to a water-loving or hydrophilic surface, it fundamentally transforms.
Yeah, because the surface loves water so much, it essentially grabs onto the oxygen atoms. And that forces the H2O molecules to align into this really dense honeycomb-like lattice.
So it's physically rearranging itself to fit the environment. I mean, that is wild.
It is wild. And that structural shift physically squeezes out any impurities or dissolved substances, which creates what Dr. Pollack calls an exclusion zone, or easy water.
Oh, okay, so the chemical structure actually becomes H3O2, acting as this viscous, gel-like phase that holds a negative charge.
Exactly. It holds a negative charge.
Well, hold on a second. A battery needs separate positive and negative terminals to actually work. So if water is just H2O rearranging into a lattice, how is it separating charges to become a biological battery?
Well, it needs an external power source to force that separation. In nature, that energy comes from radiant energy, specifically near-infrared light from the sun.
Oh, so that ambient light energy literally splits the water molecule.
Yes. The negative components build the easy water lattice, while the positive protons get pushed out and just diffuse away.
So you have a negative zone right next to a positive zone, separated by a membrane-like structure. I mean, it's literally the definition of a battery.
And it mimics the very first steps of photosynthesis in plants, where solar energy splits water to fuel growth.
I read the section about human capillaries in the notes, and it honestly broke my brain a little bit.
Oh, the part about the red blood cells.
Yeah. Our blood capillaries are often narrower than the red blood cells themselves. Like the cells have to physically contort just to squeeze through.
Right, which means mathematically the pressure from our heart pumping simply shouldn't be enough to push blood through that massive amount of resistance.
Exactly. So what's actually pushing it if the heart can't do it alone?
It's the stored radiant energy in this fourth phase of water. Because our cells are packed with macromolecules, practically all the water inside you is touching a hydrophilic surface.
So most of your internal water is actually this liquid crystalline easy water.
Yes. And the energy it stores drives the flow through those tiny hydrophilic tubes. It powers vascular flow in plants, and the math suggests it significantly supplements cardiac pressure in our own cardiovascular system.
It even seems to solve atmospheric mysteries too, like cloud formation.
Oh yeah, that part is fascinating.
Right, because if aerosol droplets in the sky have negatively charged easy shells, basic physics says they should repel each other. But instead, they condense into clouds.
Acknowledging this lattice structure gives us a mechanical explanation for that. The positive protons pushed out of the EZ create a sort of glue between the negatively charged droplets, holding them together.
It just turns these strange anomalies into totally predictable mechanics. Which brings us right back to that boiling tent in Oma's backyard.
Right, where his friend Steen suddenly bursts through the flap.
Yeah, he wakes Kesser up, yelling to see if he has heat stroke.
Because Steen naturally assumes his friend is dangerously cooking in a 50-degree tent. But meanwhile, Kesser is just lying there subconsciously processing how all that intense radiant heat is actively splitting molecules.
He was literally charging the easy water in his own cells, like a battery charging in the sun.
Exactly. He wasn't overheating, he was recharging.
Which leaves you, the listener, with a really interesting thought to ponder. If our biology is designed to act as a light-powered water battery, fueled by ambient near-infrared energy, what happens as we spend 90% of our modern lives indoors?
Surrounded by glass that blocks infrared and sitting under artificial LED lights.
Right. Are we not just stressed and tired, but literally running on a low biological battery? Picture a canvas tent.